Okay, so I'm going to explain to you insulin resistance using the figure 8 model, and I just want to show you how it should look, and then I'm going to tell you what it will look like in an individual in a disease state where they're insulin resistant. So our stimuli, for a first stimuli, is going to be an increase in blood sugar, and this stimulus is going to go to our hypothalamus, or the control center of our brain. And this is going to tell our effector organ that receives the signal, which is the pancreas, the beta cells of the pancreas, to release a hormone called insulin. Insulin is going to be released into the bloodstream, and it is going to bind to insulin receptors on the surface of the cell membrane, and it's going to cause GLUT4 receptor proteins to rise to the surface of the cell to and this causes the door to open, the GLUT4, and glucose is able to enter into our cells and help fuel our bodies, and that's going to cause a decrease in blood sugar. And we're going to go back to the middle again, which is where we want to be, homeostasis. Woo! And we're going to call this the fed state because this is after you eat like an ice cream cone or a carbohydrate or something. And we're going to come back down here, we're going to go a decrease in blood sugar. And we're going to go again to our hypothalamus. It's going to go to our effector organ. It's going to be the pancreas again. But it's going to be the alpha cells are going to be triggered to release the opposing hormone, which is glucagon. And we're going to call this the fasted state. So in the morning when you wake up and have breakfast or after a workout or something, your body's going to be producing this. This hormone is going to come and allow the liver to convert stored sugar, which is glycogen, into glucose to be circulated into the bloodstream to help increase blood sugar, and some of the sugar also comes from muscle tissue. And it's going to bring us back to homeostasis by causing an increase in blood sugar. So this is how it's supposed to look to regulate itself. Same on each side, opposing hormones, but to causing a homeostasis ultimately. In an insulin-resistant individual, their loop is going to look more like this. High on the top, low on the bottom. This is someone with type 2 diabetes. Type 2 diabetes. Now, the error occurs is when their body does produce the hormone insulin, but it doesn't respond to the insulin it rejects the insulin. So insulin comes and it tries to bind to the insulin receptor, but it rejects it, so insulin stays in circulation. And this causes you to stay in this top loop. Now, that's going to not allow you to come back down here to the fasted state, and you're going to just continue to be hungry and hungrier, and your body is actually going to store the sugar that's in excess circulating the bloodstream, store it as fat, and you're just going to have really just a dip in energy. You're going to feel tired and lethargic, and that's going to cause you to want to eat more carbs, and that's going to cause your cells to produce more insulin. But because you cannot utilize the insulin because the receptors reject the insulin is, again, going to stay in circulation and keep going and going and going, and the fat's going to be turned into, or the sugar is going to be turned into fat and stored around the body as visceral fat, which causes lots of problems. So that is why our figure 8 loop now looks like this. And this is not what we want for homeostasis, again, because we want to drop down to the fasted state so that we can be burning that fat and utilizing the sugar and utilizing our lack of sugar and coming back up here to increase blood sugar and then coming back up, and this is what it should look like, and this is what it looks like in individuals who are insulin resistant. And it can cause a lot of other problems, high blood pressure, again, extra stored fat, and yeah, we'll call this the fed state, the fasted state. This is also the anabolic pathway and the catabolic pathway. This is just like building up of smaller molecules, the breaking down of smaller molecules, and this is how people burn fat, and this is the storing of fat. So this is what it would look like in an individual with insulin resistance, typically found in type 2 diabetes. So yeah.